What is this? Today, the 30th? 32.8. Proving its angle relationships, isn't it? Okay. Okay, so we are live. Been live for 20 seconds, and here I've been fiddling around. So, today, you need to know a few things that we haven't discussed yet. But I think whenever we talk about them, you're going to be like, oh, yeah, that makes sense. So, we have this thing called the supplement theorem. Now, the supplement theorem basically says that if you have a linear pair, now linear pair, remember, means two angles that are adjacent that make a line, right? If you have a linear pair, the angles are supplementary. Now, it should make sense, right? Supplement theorem, supplementary. Anytime you're dealing with supplementary, your theorem's going to be the supplement theorem. If you're saying these two angles are supplementary, it's going to be the supplement theorem. You could also say definition of supplementary angles. That would also work, okay? And then we have this one. So what do you think the complement theorem says? Yeah, so it says that if you have two angles that add up to 90 degrees, they are complements, right? It also says if you have two angles that add up to 90 degrees, and then you have one of those angles and another angle that adds up to 90 degrees, that these two angles right here are congruent. Now that just makes logical sense though, doesn't it? Because if these two are the same angle, then these two would also have to be the same angle if they're adding up to the same thing, right? Okay, that's pretty much what you need to know for what we're going to do today. All right? So then let's look. By the way, you are going to like this one so much better than yesterday for a few reasons. One, because this is day 2, so you've done it before. So it's not new. It's not brand new. 2, this one's just going to be a little easier for you. And 3, there's more math involved in this. Okay? So if we look at number 1, so what it wants us to do is find the missing angle measures and give the reason that we are reasoning. What would our reasoning be? So that's going to be like a theorem, okay? So on this right here, they tell us that the measure of angle 2 is 57 degrees. Tell me what you know about these angles. They're adjacent? Yes. What do they make? They do. What is this? Let me rephrase that. What is this? It's a line, right? So it's two angles that make a line. That's a linear pair, right? And what do we know about a linear pair? They're supplementary, right? So that means, what do we know about angle 1 and angle 2? They add up to 180, right? And if we know that angle 2 is 57 degrees, how do we find angle 1? 180 minus 57. What's that going to get us? So 10 minus 7 is 3, but we borrowed from this, so it's going to be 7 minus 5. What is it? 123. So 123 is our answer. Now we need to supply our reason. How do we know that how do we know that we can do this? It's one of the ones we just talked about. Supplement theorem. supplement theorem. That's how we know. That's our reason. Okay? All right, let's look at number 2. So, measure of angle 5 is 22 degrees. I'm going to mark that on my diagram. Tell me what you know. This angle over here is 90, right? And we know that because it's indicated by the square. Okay, what else do we know? So all together they have to equal 180 because they make a line, right? So what does that tell you about 5 and 6 together? They have to equal 90 because if this is 90 over here and they all add up to 180, then these two together have to be 90, right? How can I find angle 6? So if I do 90 minus 22, that'll get me angle 6, right? 68. Now what's my reasoning behind this one? It's one of the things we talked about. Complement theorem. Because what do we know about angle 5 and angle 6? They're complementary. So it's going to be the complement theorem. Alright, let's look at number 3. So number 3 I didn't actually talk to you about because I think you're just going to remember this, okay? Tell me what you know. Okay, 1 and 2 are congruent angles, aren't they? How do we know that 1 and 2 are congruent angles? What kind of angles are they? They are vertical angles. So our reason for this is called vertical angle theorem. Vertical angles theorem. And basically vertical angles theorem just tells you that if you have vertical angles, they're congruent to each other. Right? So if 1 is 38, what is 2? It is also 38. So the measure of angle 2 is also 38. Y'all see how easy that was? Look at y'all kicking butt. Okay, number 4. So on number 4, they tell us that the measure of angle 13 is 4x plus 11. And the measure of angle 14 is 3x plus 1. Now, what do we know about 13 and 14? Just based on the diagram, what do we know? They have to add up to 180. They are a linear pair. A pair of angles that are adjacent that make a line, which means they're supplementary, which means they add up to 180. So if we want to make an equation out of this, we would say that 4x plus 11 plus 3x plus 1 equals 180 degrees, right? So we've got 4 and 3 is 7x, 11 and 1 is 12, right? Y'all following me? Now what? Subtract 12. So we've got, I'm going to sort of jump over, like, where am I going to go? I'm going to go over here. So 7x equals 168. Okay. Divide by 7. And what is x? 24. Are we done with that problem? No, because they didn't ask us for x. That's not what they asked for. They asked us for the angle measurements. So now we got to take that 24 and put it back into one of these equations. So I would do 3 times 24 plus 1. That's what I would do. So what's 3 times 24 going to be? 72, 73? So that's going to be 73. Now, to find this one, we can either plug in the 24, or we can do 180 minus 73, because we know they add up to 180. Now, sometimes it's a good idea to go ahead and put it in. That way you can tell if you made a mistake if they don't add up to 180. So if you plug it in and they don't add up to 180, you made a math mistake on your equation. Okay? So if we do, why is my phone not on silent? Okay. I don't know why it's not on silent. It should be. I have it set to where it automatically goes to silent. All right. So then what's our other angle? 108. Is that right? 107. 107. Okay, so what's our reason on this one? What would we use as our reasoning? What kind of angles are they? So our reason is supplement theorem. Okay, that's our reason. Supplement theorem. All right, so let's go to number 5. So number 5, they tell us that 9 and 10 are complementary. So what does that mean, complementary? They add up to 90. So we know 9 and 10 make a right angle. 7 and 9 are congruent. So we're going to mark 7 and 9 as congruent, put the same little symbols in them. And 8 is 41. So based on that information, tell me what you know. 8 and 10 are going to have to be congruent, right? So this one right here has got to be congruent to this one right here. So if that one's 41, this one's 41. What else?
They're all going to add up to 180.
They're all going to add up to 180. So how can we find 7 and 9?
You could subtract 41 from 90.
Mm-hmm.
To get one of them in there.
That's right. So we can take 90, we can subtract 41. What's that going to give me?
41.
So that means 7 is 49. What about 9? Also 49. What reasoning did we use on this? We used complement, didn't we? A lot of people want to say supplement, but we did not. We used complement. It was all about the 90, right? Okay, so let's look at number 6. The measure of angle 2 is 4x minus 26, and the measure of angle 3 is 3x plus 4. What do we know about those? So that means they're equal to each other, right? They're congruent. If they're congruent, their measures are equal. So that means that 4x minus 26 has to equal 3x plus 4. Now can we do that math? What do we do? Combine like terms. Okay, so what would you do? So move this guy. So how do we move him? Subtracting. So it's going to give me x minus 26 equals 4. Now what? Plus 26. X equals 30. Is that my answer? No, because they didn't ask us for x. They asked us for the angles. So now we've got to take that 30 and plug it back in. Do you have to do it on both of them? They're going to equal the same thing. It is smart, however, to put it in both of them and make sure you get the same thing. Because if you put it in and get something different, then that means you know you made a mistake somewhere. Okay? So the answer should be 94. Is that what y'all got? What theorem did we use? What? You may be right, I just couldn't hear you. What? Are they actually triangles though? What kind of angles are they? Starts with a V. Vertical. So we use the vertical angles theorem. Vertical angles theorem. Okay, so we're going to do a proof down here. This proof is going to be a lot easier than when we did yesterday.
It's so small.
It's what?
It's kind of small compared to the other one.
Is it smaller?
A little bit.
Oh, it is well, 2 lines smaller. It's 2 lines smaller. Okay, so here's the information that they're giving you. They're saying that angle QPS is congruent to angle TPR. Okay? Angle QPS is congruent to angle TPR. So QPS, that's this angle right here. Y'all see that? It's congruent to TPR. That's this angle. Now, just right now, tell me what you notice. They look obtuse, okay? What else? What else do you notice about them? They share something, don't they? They do share their vertex, but they share more than just the vertex. You're on the right track. They have an angle in common. Do y'all see that? This angle right here is part of both of the angles that we're talking about. That angle has to be the same in both of them. Do y'all remember I was talking about the reflexive property and how RPS has to be the same as RPS no matter which shape it's in? Remember I was discussing that? Now, they actually didn't include that in this proof. I would have if it had been me, but they didn't. But that's okay. So, and our goal is to prove that QPR, that's this one, is congruent to TPS. That's that one. So we got to prove that they are congruent. Now, your brain has already jumped to that they are, right? We're just walking down the steps that your brain's already went through. So we start with, what do you always start a proof with? What did we start with yesterday? The given. So what did they give us? Well, they said that angle QPS is congruent to angle TPR. And how do we know that? It's given. So we're just going to put given there. Okay. Now, in our next step, what changed from here to here? What's different? So up here they're saying that they're congruent, and down here they're saying that their measures are equal to the same. So does anybody remember how we give a reason for this? So yesterday we were talking about segments, right? And yesterday when we were talking about segments, we said definition of congruent segments. Today we're not talking about segments. So we can't say definition of congruent segments. What can we say though? Definition of, I'm going to abbreviate, congruent angles. Okay? I'm just going to abbreviate to make it faster, shorter. We don't take up as much time. Okay? Now this next one. They tell us that the measure of QPS equals the measure of QPR. So QPR is this guy. And RPS, which is that guy. And then they tell us the same thing about the TPR angle. TPR is TPS plus RPS. Now, we also did this yesterday. We added together 2 segments to equal another segment. What do we call that? Segment addition postulate. But these aren't segments. So what are we going to say? Angle addition postulate. Okay. Now, what do you think is the most logical step for us to go to? This is the one place where I feel like they just sort of dumped you off and was like, sink or swim. So, from this point right here, where do you think we're going to go with this problem? What do you think we're going to do here? Say it again. Yes. Yes. So we know that QPS and TPR equal each other, right? So we know that what adds up to get them equals each other. So we can take this and we can put it in that place right there. So now it's going to say the measure of angle QPR plus the measure of angle RPS is congruent to the measure of angle TPS plus the measure of angle RPS. Now, does everybody understand why we did that? So we just stuck this right here that equals QPS in the place of TPR because we know QPS equals TPR. They are the same thing. So we're just substituting. See how our reason is substitution? We're just substituting that in the place for this other one. Now, that's one of those things that just the more you do it, the more you'll realize that's what you need to do. Okay? Okay, so then our next step. Well, let's look at that for a second. What do you notice about both of these? Both sides of this.
They both have RPS.
They both have RPS. So y'all know what we can do, right? We can take it out. Now, yesterday, they actually did a line where they showed you they were taking it out. We don't have to do that. We can just take it out and then say that we took it out, right? So, if we take it out, what are we left with?
Measure TPR is congruent to measure TPS.
Now, how did we get from this one to this one? Well, we subtracted that measure of angle RPS, right? If you subtract it from both sides, you can do that. That is our subtraction property. I just went so blank. Property of equality. Okay? Now, so this says that the measures are equal, not congruent. The measures are equal, right? This should have said equal also. I goofed up. Those are measures. That should say equal. My bad. That should say equal. So what is our next step? We know their measures are equal. What does that tell us about the shapes? They're congruent. So that means that angle QPR is congruent to angle TPS. Now that's going from the measures to the shapes. Any guess what our reason's going to be on that? What's our reason going to be? What, Donovan? How do we know that the measures of angles are the same if they're congruent? Like, how do we know that? So, yeah. So it's going to be definition of congruent angles. That's how we know it. So a lot of times people want to write the word prove down here, but that's not a reason. That's a command. That's telling you to prove that. Okay, so we actually finished this quite a bit earlier than what we did in second period, but I got a new student in second period and that took up a lot of time. Tomorrow you are going to be doing 2-7 practice and 2-8 practice. So you're going to have 2-7 practice, which looks like this. It's one proof you're filling in the blanks, and then the second one is you're going to write your own proof. Okay? And then 2-8 practice is only 5 questions, and 3 of them are going to be really basic, and you're going to write a proof and then answer a question. There is no reason you can't finish this tomorrow. None. That's 5, 6, basically 7 questions. Now, a couple of them are kind of long, but still. Still, okay. If y'all want to work on it for 15 minutes, that might be a good idea. You got 15 minutes left.
Do all the basic questions.
Yeah, do all the easier stuff today. No, it is not in the Chromebook. I may not put it in the Chromebook. Let me think on that. Because we don't have any way of writing math.